Shall we start?
Yeah.
My name is Sebastian. I'm a senior data scientist at Avaus, and me and Gus will present. I will start. And Gus, please introduce yourself if you want.
Sure. My name is Gustav Maskowitz, and I'm not a deep learning tech working at a deep learning company. I've been lucky enough to be technical my entire life, and joining here with a room of PhDs, I feel remarkably stupid. So please keep that in mind later, so I can build stuff, but don't expect too much.
Yeah, Gus will actually show you how to build the deep learning models in Peltarion Platform. My point is more to put you in the context of the importance of engineering when it comes to deep learning and machine learning in general as well. So let me see. Yeah. So this is my agenda. I have 4 points before Gus takes over. And the main theme of my introduction is what I call the gap between data science and production. So if we have data science on one hand and production on the other hand, I see at our clients like a huge gap. So what it means is that every company needs data scientists nowadays. There's a hype, the train is leaving the station, everyone wants to get on. Everyone hires data scientists, they put them in their corner to try and build a lot of models, but only a few of them, if any, ends up being used. And I thought of this, and I think it's very weird that how come we spend so much money on data scientists, and how come they spend so much time, but very few models actually gets used in the end. And I have boiled this down to 3 points. There are, of course, many more, but I think there are the 3 main ones I want to talk about today, which is basically engineering, where we see a huge lack of engineering skills when it comes to our data science competence. In general, not of course everyone. The second thing is communication. Data scientists are often from an analytical or technical background, so they don't speak the business language, basically. So there's also this gap between the data scientists and the stakeholders who actually take the decisions of putting models from a proof of concept stage into production, which actually allocates resources for that. And the last part is what I call the...
It's not updating. It's pretty odd.
It was, I think.
Oh,
perhaps my...
yeah.
Troubleshooting
the wrong thing.
Okay.
Go ahead.
Yeah. So the last part is the endless tuning. So even if the first 2 factors are in place, I see a lot of data scientists being stuck in like endless tuning of their models. They try to do different experiments with their models and they run in circles. So when it comes to the engineering part, I call it Mount Engineering because I think Oliver demonstrated, he had a slide where like your model is just like a small part in the middle of a big like technical architecture. And as a data scientist, which is one of the most sought after roles right now, we see a problem, in my opinion. It's a good thing that many analysts rebrand themselves as data scientists and go towards that point, to that role. But what they often miss is, if you come from a mathematical background, let's say mathematical statistics or physics, you often lack the pure software engineering skills, which means that you're great at building models, doing feature engineering, etc., tuning your models, but you're good at it in your notebooks. So what you have is a lot of models in your notebook or on your own computer, but you don't really have the skills, like the pure engineering skills, to put your model into production, to integrate it into this kind of extract, transform, or load pipeline, or even exposing it through an API so that someone else can use your prediction model. And the consequence of this is that your proof of concept model stays in your notebook, and it's never used. So this would require then a lot of manual labor every time you want new predictions from your model. You need to basically export it to some kind of CSV perhaps, or have a database connection, do everything like in your notebook, export it to a CSV file, and then hand it over to the one who needs your predictions. So in the end, many models are built, but no one is used, or a few of them at least. So the alternative would be to get resources from your engineering team. But that turns out not to be the easiest thing. Because as a data scientist, we talk about like features, target labels, we have our accuracy, we have our measures for model performance, etc. But what we see is this situation where a data scientist in their corner says, oh shit, I have a really good model here. We have a precision of that and a recall of that. And then like the manager says, what are you talking? What language are you talking? Like we need to be able to do, to retain customers, or we need to be able to increase awareness or whatever. So there is a big gap between the technical terms the data scientists use and the stakeholder who actually has the power or influence in the company to say, we need 2 resources from the engineering team to put this model into production. So if the data scientist cannot make himself or herself understood in terms of business value, well, no one is going to be able to take the risk and spend resources and invest into your models which you have built to put them into like a production environment or exposing it through an API. So if you lack the engineering skills yourself and you don't have the language framework to talk on the same wavelength as your stakeholders, then what will actually happen is you're stuck basically in your proof of concept land. And the last thing, even if you have the engineering skills or you have resources from another team who has the engineering skills, what I see is like when you build a model, you're never satisfied. There's always this parameter you can just twinkle with a little bit or tune. What if I just change that parameter? Is the model going to be better? Or what if I pre-process this feature for my model, which I put into the model? If I pre-process that in another way, will that increase the performance of my model? Or, well, if I build many models, but for solving the same problem, well, did I now train my model on the same subset of observations, etc.? And then after a while, you start to realize, oh, what was the performance of the models I built last week or last month or whatever? So there is this situation where you run in circles and you try to chase like few percentage points in accuracy or precision or recall or area under curve or whatever, where the best thing would actually be to move on to build the next model. And I think this is a bit of a provoking image with the intent of being so. It's what I call POC city, like proof of concept land or whatever. It's where you have great fun, like you start at a company and you have like all the data and you have like endless possibilities. You see a lot of models you can build, a lot of problems. So you do that, you go and build your models. But due to the 3 problems I brought up, you end up with no models being put in production, and you try to convince people like, I've spent 3 months now building all these models, why don't you use them? And you basically give no value to your company. You start feeling insufficient perhaps, or even unappreciated. So you start applying for a new job, and then you repeat the process basically. So when it comes to the engineering part, I think that is the one which is the biggest one, the biggest hurdle of them all. And that's what I appreciate, like being a partner with Peltarion, because I'm actually from a software engineering background, so I know this is why I know like the engineering part is a problem, first of all, and also I appreciate that as a data scientist, I don't want to spend time on this engineering part because I think they are boring. I would rather do more of feature engineering or building models, solving more problems. So I hope that that you share my view, and that perhaps Gustav can show you like how they have solved many of these problems.
Awesome. May I?
Yeah, sure.
Thanks, man. So I realized my introduction was perhaps a little bit too humble. The reason I started in data was as a site reliability engineer for a big online video system. It was my job to keep these thousands of machines online and get videos streaming and terabytes of data in a certain way. That led me to, like, I was a product owner for a data-driven product. This was 2014. I didn't have deep learning skill back then. Anyway, so that's what led me to finally be at Google and to finally be here. I'll be telling you about AI and marketing today, but before doing so, what's the feel in the room today? So you put your hand up earlier, you've done things in production, you're a data scientist, engineering background.
I'm actually a statistician, but I've done quite a lot of software engineering.
Got it.
Actually, as well.
Got it. So your base is mathematics and stats. Yeah. Normalized values make perfect sense. Yeah. And software engineering.
I went to split down, sorry.
All right.
Thank you.
Thank you. Who else is of this stats first math background? Okay. Any computer science background in the room?
A little bit.
Yeah. Okay. I would say a little bit. I'm a hacker, not an engineer, and a technical buyer of something. So it's your job to choose the right tech to solve a problem.
A little bit between all these characteristics.
Yes.
Having a team, which is where we are doing like visual coding for.
Understood. So what in preparation for today, it's a bit of a joke, but it turns out to be quite insightful to make these, and I'll let you in on the joke a little bit later. But it's how to do something that's really in production and landing. It has some surface on the road, even from a skill level like myself. So before we go into too much detail, this is the method is always to tell you what we'll be talking about, so you feel a bit more connected. It's very important that you figure out what it is that you want, because many people just want to know about AI, and that's great. But sometimes it means everyone wants to be trained up, and then they'll start their product. Some people may just want to get something in production, and you pay somebody much too much, and they sell you snake oil, and then you've bought this SAP SaaS weird thing that predicts sales, and you have no idea how to drive it, and all you've done is given away your future to somebody who charges you billions of pounds every year. So somewhere in between is a really good idea. Start scaling yourself up, but plant a flag, not in the too distant future. 3 months from now, you want to be able to predict per store the sales, or you want to categorize your customer based on their telephone behavior, or you want to figure out what is the best influencer to put on screen if you have 30 seconds to see somebody's going to buy motorcycle helmets from you. But something about their cookie history, you can figure out what classification, what group they are, and if you put on a male or female, or Tony Hawk in my case would be more enticing than a snowboarding person because I don't know them. That is the kind of things that really do move the needle. Because if you think about marketing, your job is to get the news out so people do something. And currently you do that with metrics. That's great. But what if your spend could be spent a little bit differently and increase one of those areas of effect? That's quite fascinating because you do it with your human skill, but interesting to find out what a computer can do for you. There's something called the Red Queen effect, which we'll go into a little bit deeper. I was lucky enough to be in a conversation with one of the founding members of Google Translate just last week in Berlin, and they did a huge amount of rule-based phrase-by-phrase translation, and they built software that would withstand nuclear attack, would outlive us and our children. And he said that was absolutely the wrong thing to do, because every single time you change the tech underneath, you go, oh, and you have a year of doing something differently. And then when the tech underneath changes again, you realize, you have a year of translating. So they now they keep in the same perpetual mess as Google search. And something I've also realized that if you hard code things too much, let's say you build a deli and you build the booths and you cement everything in, it's a perfect deli. You can't then turn the chairs around and turn it into a makeshift video for the after school kids. You can't suddenly have 100 people watching a movie and then have it at a food hall again. So there's this idea of if you build it too rigidly and too strong and too good, which is an engineer's instinct, then you're wasting your potential impact. And then lastly, you have to be prepared to throw your code away. We'll get into more detail of why and how, and the demo that I'm doing is exactly on that line. And in that method, the underlying thing is invest in ways to do more with less. Okay. This we touched on, you touched on it perfectly. If you have this idea that you want to predict sales outcomes, make sure that somebody in your business has a reason for it, or that you plant a flag and people say, we want this. And that once you deliver it, you know that you have it, and that you're in a position to say, well, then we keep it in production. And you put it in your calendar to replace it every 6 months. So something that often happens is if you work in R or Python, you figure out how to do sales predictions and you go, great, this is now done. Your business intelligence team use a .NET stack and as a database, and maybe they productionize things in Java. You've given somebody who may be an inferior programmer to yourself a job of implementing something that's really quite precious. If they do it badly, your work doesn't actually land, and there's this friction. So you have to figure out anything that you build should ideally be usable in production, anywhere that you want. If you can code it up as a Docker container, and the Docker container runs somewhere in your environment and it says thumbs up, thumbs down per customer, give a loan, don't give a loan, the sales prediction for next week is going to be 50 bottles of milk versus not. That's great. So we happen to have that system, doesn't mean that you have to use it. There is something called the Red Queen effect, and this is from Lewis Carroll's The Follow-Up book from Alice in Wonderland. The Red Queen tells her, so here it keeps all the running to keep in the same place. And this is it's obviously a surrealist place. And it's the metaphor here is in economics, if somebody stands up because they can't see the football match, then other people can't see and they stand up, and before long everyone has stood up and everyone's back to where they were in the beginning, except something happened. And in AI you face the same thing. Everyone is chasing this AI-enabled, doing predictions, but the moment we all get there, we'll be in the same competitive space as we are right now. So it almost feels like we're chasing to stand still, but then when you see the Darwinian and the evolutionary side of the Red Queen effect, if a predator has a method of seeing the dark and the prey can't, then they just die. And the ones who can see, you have this perpetual struggle, and the ones that keep adapting. That's actually the message here. It's your adaptingness, how adaptive you are to external forces. That is the muscle you have to exercise. Not a specific muscle. This ability to change very quickly is very, very important. Another thing from a conversation last week at least, with the Google Translate team is start where there is data. In other words, don't do what they did. They created the data sets of English to Portuguese or Portuguese to Taiwanese. He says it's absolutely the wrong thing to do. You have to look at what you have and then figure out what you'll do with it. Because sometimes it's just a question of labeling it. Like, is a customer a good customer or a bad customer? This behavior leads to them churning, meaning leaving their contract or not. This person is creditworthy or not creditworthy. Some labeling is probably in your future, but it's very important the analysis of looking at what you have is crucial. So if you're going to do anything, is plant a flag 3 months from now based on something that you have. That's the only call to action that I can give anyone purely to move us forward. This lines up to that idea that when you go from a rule-based translation system or from XGBoost and predicting sales, when something changes and you have new hardware or you have a new pipeline or you have some dependency on Java or a dependency on Neo4j, you have to be prepared to throw your code away. So the stuff that you invest in, your work, you have to be prepared to say, 3 months I work, 3 months in production, and then snip. The umbilical cord is snipped. Maybe it's in the trash. Maybe it is It's in production, but you have to be prepared to not be too wedded to what you create in order to be as fluid as we need to be. And again, with this underlying structure, anything that you do should be allowing you to do more with less. That means you plant that flag, you look at what you have, start scaling up, look at any training that you want, but also find somebody to come help you. And then this is extremely true, that there's opportunities for this all around us. One of the examples that Oliver touched on earlier was for epidemic sound, the model that looks at a snippet of sound. We turn the sound into a picture, and from that picture we use a convolutional neural network, which we'll be doing now, hands-on. Well, you don't have computers. But from how the song looks, you can say, oh, this is angry or casino music or epic music or funky or smooth. Turns out the exact same method works. If you have 5 or 10 seconds of telephone voice, you can say this is a neutral conversation. You can overlay that with what is understood with not neurolinguistic, but natural language processing. If somebody's saying, look, everything looks fine, I'm happy with the price, you record the text because there's a speech to text and text understanding. But if somebody says, that's great, and slams the phone down, if you don't have the melody of the voice, you'll be recording, that's great, and you think this is a happy customer. And in fact, there is something that could be done to that relationship that will potentially move the needle if you are dealing with Shell and it's the main buyer for some reason and they're about to not fund your activities. You need to know about this. Just like in a live call center environment, it'd be pretty great if you saw the different conversations and you see conversation go green, then orange, then red, and you go, little Timmy is having a terrible day in the back corner. Walk up and say, can I help you with it? Because service and need needs to overlap, otherwise you just miss the ball completely. So it's extremely transplantable things. And that, the tagger example, the epidemic sound tagger, is a tutorial on our website. You can do the entire thing. We explain how, there's a data set to train on, and then you have a model that can say 1 of 46 or 5 out of 46 things are true in a song. And that same, with a different data set, will say 1 of 3 things are true when you hear every 5 seconds of a voice. Anyway, let's get hands-on. About a month ago, our CEO said, wouldn't it be great if there was a way to say, is what I'm producing, this presentation or a piece of social content for LinkedIn or Instagram, is it on brand? And I thought that would be pretty interesting. And I set out to prove that it is interesting. So I created my very own cat food. Very welcome to Zippy, for the love of cats. This is my cat food brand, and it is very stylish and extremely hipster. Only the best hipsters feed the very hip, only the best cats this cat food. But this is the previous brand. So we pivoted away from this brand, and this was specifically my daughter's favorite. This was our previous brand, didn't get the same kind of buy-in from the hipster community, and now this is the new brand. So I mocked up this data set. Let's move here to the side. I want to show you what I did. Here in Google Slides, I created a couple of slides, created a few examples of it, and then created a data set of what is not, or at least what is the old brand. And I have only 58 pictures here. 58 because I ran out of time. I did this in a meeting. I wasn't required in a sales call, so I thought, I'll start. So I created this data set. I exported this as PDF, download as PDF, where it is, and then using Image Magic, they have a convert command. You just go convert this PDF to some name, %02d dot whatever, and it just rips every file out, and you go, oh, now I have PNG files. I have pictures relating to this. Pop over to the Peltarion platform. I can build a model. Maybe before I do that, let me show you an example of my working brand detector. So that is something that isn't in a training set. It fits the feel of my brand, and I'm going to hit there, and it says, this is of the new brand variety. And if I give it something of that wasn't in the training set, maybe that's a good example. That is of the old brand. Great. Maybe it's just doing the colors, maybe it's doing the thing, but I have tested this a little bit. It is understanding and looking at different parts of the picture. It's not, if I were to do this for real, I would find locate the brand, or like at least locate the logo and highlight the logo so that you can then rip that out and do an exact overlay of the previous two and see if it's out by a few seconds if somebody tilted your text, etc. But that was going to take too much time. But what you're looking at here is the contact surface, the operational contact surface between something that can use a deep neural net, which is an API, a RESTful API, and this token, which is like a username and password mushed into one. That is it. That is the window through which you work, and you get a usable result. Let's go into how I did that. I simply made a data set. In fact, here in ZippyCat, let's see quickly, one of these 12 March bundles. So that's only 2 megs in size. That's extremely small, but I'll call it all right. Can you see? How's the text? What you're looking at is the Datasets View. There's 4 tabs at the top. In this tab, I'm going to be handling and doing statistics on my data. It has been pre-computed outside, so I've resized the pictures down. I mentioned earlier that I used a PNG file, and when it came to deploying in this little app that was written for our MNIST handwriting recognition, I realized that the JavaScript underneath was resizing the image and posting it as JSON, as JPEG, and it had only 3 channels. And the PNG file wasn't working because I was including the alpha channel, the see-through. And I quickly then just changed again using ImageMagick to convert, changed to JPEGs, retrained everything, saw a better result because the images were also quite smaller. And now it could work through this interface. And that entire process here under modeling, I could track the changes that I used on different models and just rip out, copy an example, you copy an experiment, you change the data set that it's based on, you click run, and then you have a new endpoint. And you can go back to the different ones using PNG files, using different examples. So if somebody were to audit right now and say, what did you do? I honestly iterated so much on the last month that I can't tell you every change, but there's a log of the changes. So somebody can go re-implement this and put it in production, which is one of those outflows of just somebody handling the complex stuff. Just like a car, I don't have to build an internal combustion engine every time I want to buy a new car. You just choose it off the shelf. Here in Datasets, we just created the set. You'll notice you have an option there. It's auto-selected to one hot encode, which just means it noticed there were 2 strings in that column. The one said new brand, the other one said old brand. And it turns that into a representation of a little 1s and 0, so that the model, ultimately the model is effectively a function. A picture goes in, as a function that you can't see the math that it's doing. It's going to run, and 2 fingers almost stand up at the end. The one's going to lift up for old brand, the one's going to lift up for new brand. And it lifts up by a probability. It's going to say the probability of this being the new brand is 0.98, and the other one's low, or vice versa, or sometimes interestingly in between. Here you have the option to do something called min-max normalize, which I studied applied math and computer science, but I never finished it. I was working at a venture capital firm at the time, and I just didn't finish. But turns out this brings all the values to between 0 and 1, and your model has less space to, or at least it's, everything's a little bit more dense, so that, I don't know how to completely say this, but otherwise your values are between 0 and 255, and it's not as easy to get a working probability out if the space you have to guess about is so big, so you squash it. So we'll be doing that. I'm making a feature set, meaning the input is going to be an image. See there? 224 by 224 by 4. This is a PNG data set that I use. So actually, I would like to not do that. Excellent, it's fine. We won't use this model. Feature sets are usually what you do. If this was Keras and I was doing some kind of self-prediction or exactly the same problem, this is, honestly, it feels a little bit too much to try and do in the time while I'm on a phone call. It feels too involved, and quite honestly, I don't think I could do that, but I can do this. And picture, wait, this is the out value. Is a class, and you see it's of shape 1. So let's take an example of what I did yesterday. The input here was a 224 by 224. So a picture, turns out, any picture or a waveform is just like a spreadsheet. It's got rows and columns. It's a matrix of, well, it's an array or a matrix, I forget. But it's, you have different data points, and in the convolutional neural network, which is the type of thing we'll be doing here, you have a 3 by 3, imagine a lens. In fact, there's a good example of that animation here. Every single pixel of a picture is a feature, and the pixel existing or not existing, imagine a black background and a 1 drawn over it. The white keystroke of the 1 would be switched on pixels, and the black ones are switched off. And the little 3 by 3 lens would be clicking over it and assigning numerical values to the things that it sees. Once it gets to the edge of the 1, it says, oh, now there's nothing, and here's something, and in the middle of the 1, it goes, everything's switched on. So it has a representation of what's happening. What's truly weird is that this works for more complex things, like the texture on the animal in the basket. So a model that is trained on 2 things, cat and dog, won't be recognizing the basket or the clothes or everything else. If it was trained on dogs and cats, you can show it an Aston Martin, it won't even know it's a car or a nice car, it will just make up randomness because it has no idea. But if it sees signal for cat or signal for dog, every layer, something switches on or doesn't switch on based on a mathematical matrix multiplier function. And the value is high enough for an activation function to say, yeah, you're above the threshold, I'm switching on. And if you switch on and I'm connected to you, you're getting a signal from me and from him and from him. And that means you now have to go, oh, based on the matrix multiplication we're doing and you're doing and you're doing, you say, oh, this doesn't completely make the cut, you're under the threshold, you don't switch on. And then you're one of these black dots who, that's where it stops. But if it does switch on, the layers go smaller and smaller up to the end where you have this probability hands up, hands down. Now, I chose this model off the shelf here on the side. And I just put down a convolutional neural network and I started fiddling with it a little bit. I changed the end layer here to 2, and the output, I matched it to the feature out of the data set that I used. This is the one that's currently in production. Let's look here, 224, that's the picture size, and I chose that size, not a smaller one, because there's more pixels to work with, there was more signal in that work. And 3 channels is red, green, blue. If you make it a black and white picture, you just have 1. But every pixel is completely black or somewhere between the gray or completely black. What's super cool is I can compare every example that I did, every iteration of my experiment when it was different data sets, or I can still compare how they look. So if let me backtrack for a second. A model is just a function, so it's a black box. You put a picture, something happens, and one of the 2 fingers go this one, that one. As it's doing that, in the training phase, you either have to, or every time you predict, you say, I think this is a dog, you do it with a certain energy, with a certain value, and you want your wrongness to be as low as it can be. And that's the error on whatever. What is categorical cross entropy in this case? That's the loss function.
Yeah.
Yes. So it's a way of describing how wrong you are in the training phase. Because if the model it's initiated with random weights, it would say, is it the old brand or new brand? It says it's the old brand, and you go, no, this is the new brand, and you go back to every layer, you adjust the weights, something does, it's called back propagation. Figure out how much to tune the weights going back, and then do it again, and back and forth, until the weights encoded in every one of those 27 million little values are in a state where you can give it a picture, and it can reliably say old brand or new brand. So enough of that. Let's go to an example where this starts to hit the road a little bit. Was it test set? There we go. So here's a picture where it's the old brand, it's the new brand, but it has a orange background, which is something that it has in common with the way we were doing things before. So if I give my model this picture, you ask me, what is this? It's smart enough to realize it's the new brand, but I'd like to show you quickly what is very interesting. what was that? Slightly off 01. Let's open that and check what it is. Yeah. So here in the platform under deployment, I flick this on and I have instructions here. Curl is just the command line browser. That is the, if I were just to copy paste that, that's what you're looking at here. So I'm saying post this picture of the slightly off 00 JPEG to, that's my username and password, that's the endpoint, and I'm going to pass it through this little thing called JQ at the end just to add color and to make it look a little bit prettier. That's interesting. Look at the percentage, new brand or old brand. And compare that to something where an original, that's an original picture that was part of a training set, orig 00. Let me just copy that. Orig-00.jpg. Look at how certain that is. 98% sure it's a new brand. And that's great because it is. But when I give it the slightly off one, there's a lower probability still within the brand. And now suddenly you go, well, this is a joke. But what if all the referrals that come to your website, the top 10%, if you follow the referral link back and you have a little headless Chrome browser instance, take a screenshot of that page, you cut up that page into different blocks and you do a prediction on each of the block. Do you find your brand? Yes, no. If no, then maybe a human has to investigate. But chances are they will be your brand on that page. And you can say, which brand is it? Because if you have a campaign with your new ZippyCat wonderfulness, but somebody sees the old logo, that they might think that it's a stale link or it's not in line with what they see on the bus stops, etc. And they won't actually click, which means there's a chance for you to automate and send your brand guidelines to that referring site and say, your stuff is old, you could be making more money referring to me, etc. So suddenly this joke has turned into a potentially usable case where you would A, find your brand on different sites and either make it easy for an intern, which is usually the type of people who ends up with the unglorious job of looking through things and checking if people are using the right brand guidelines. But I found that extremely interesting, that you have a measure now of on-brandness. So as if people use a pink background, but your brand guidelines say it's only ever a black background on a transparent logo, this is something you can detect. And critically, it's something that someone like me can detect, because I'm done with this now. In 6 months, I can potentially revisit this, or if it's doing its job, then it's a free REST endpoint doing 20 things a day, or potentially 1,000 times a day. And that REST endpoint was built by the people who put Candy Crush online. They know about the monitoring and how to be online. I don't have to worry about the monitoring alerts or the disk space or the pipelines, etc. It's just a case of you ping it, and it gives you a probability back, which is fascinating. And 4 hours, granted, some knowledge. In this case, I knew what softmax was, which is one of the activation functions in use. I knew what categorical cross entropy was. And the first time I built that model, I chose the wrong error metric. It was MAE, what's that again?
Not sure to know.
Anyway, it's just a way of how, there's mean squared error and different things. So I chose the wrong one. My loss looked really good, but it didn't work until I just read up 2 articles and I realized, I'm choosing between 2 categories. And if you have 5 categories, you choose a slightly different one called binary cross entropy, where it can compare this one to that one, and you can do 5 different classes. And the value that it predicts on all those 5 classes don't have to add up to 1. It's just, there's a little bit of reading, but it wasn't a blocker. I was able to get this and to ship it into a reliable state. So now I have an offness percentage detector in content that, let's say, an agency wants to, on my behalf, put something on LinkedIn, and usually they email me and I look at it and go, yeah, this is fine, here's the advanced guidelines. I could ask them to just use that little tool, and if it says thumbs up, then it's fine. If it says thumbs up by not enough, then I want to be let know.
MAE must be mean absolute error.
Mean absolute error, that's exactly the one. So now it led me to another example. And I think we're almost out of time, but that's why I'm maybe rushing. Another example that one of our researchers made was to do emotion detection. If somebody's smiling or angry or scowling or frightened or scared in a video. And the video clip, the MP4 file, was every 20th frame was ripped out, and you put it through in exactly the same convolutional neural network that would say, I was trained on 6 classes, happy, angry, sad, whatever. And you detected that moment in the screen and you give an output. But what stops you from saying every second of YouTube playtime is 50 frames? So if I rip out every 5 of them, so over 10 things, that will mean a second of exposure in a YouTube clip. What if there's 1,000 YouTube clips after, let's say it's Dota or some kind of esports online game where people are walking through the stadium and you pay for marketing on the shirts or on the cap, and you will go, did I have exposure? Because you can look at the main thing and somebody could say, yes, we were exposed for 20 seconds. But you can suddenly say, look at all these channels with this tag. The video as it comes in, every video you cut it out, and if you see my brand at all, flick it on. If you see it for 10 consecutive frames, then that's a second of airtime in that video. And that was unachievable for me. And now on top of this, the emotion detection video cutting up into frame, like, well, I have that. I've got YouTube DL, which is a way of downloading a video. So now it's just a YouTube search, which is an API. So suddenly you go, the YouTube search key finds all the videos, every video download, run through this thing, and I can say my brand was not on screen at all, and I paid £50,000 to be on a logo on somebody's cap. Well, that was a waste of money. Let's not do that. Or it proves that you have had some exposure. And that's where deep learning really comes into its own, because you can't do that with XGBoost or other statistical methods where you say, of all the data that I have, this column was the sales prediction for the shop. You build a tree that says a week, yes, no, to get to that column prediction. You do that 5,000 times, or this tool does it, XGBoost. And then you average out the tree and you end with a machine learning method that can predict that column. Great, but everything was pre-computed to be in a little cell. And you want to predict the cell. What if data is not in the cell, like hidden in the screen, in a video, or in the melody of a voice? So it's fascinating, and the opportunities are endless, but it has to do with where your data is. And that's an analysis program. So let's see, until what time do we run? I was aiming for 10.
I think we're running for 10 minutes more at least.
Okay. Now that you have your new AI muscle, it's something to flex. So I would love for us to talk about it, because we are in a smaller room, not just a big presenting at you situation. Let's go through what we went through at the beginning. You plant a flag, 3 months from now, something is true, and that's true based on your data. You have tooling that can help you cross the gap. Potentially deep learning isn't that tool, that's fine. Perhaps XGBoost is, if your data is in spreadsheets, that's great. Dealing with the change inside your business is also quite hard. So make sure that you have good friends, that you have people like Avaus, or he just left the room, as I was about to say that. Make sure that you have people who can come with case studies or say that this is what we did before, this is the impact we see, this is the return on investment, because business people, it's their job to make sure that if you spend £100,000 on something, which means people and licenses and time and energy over the next 6 months, that it has some kind of return. And what you don't want to be is get known for the smart people who just do proof of concepts, who don't actually get into production. And that's the single biggest method, is to make sure that you have a champion in the C-suite or a champion in the rest of the business, something that they care about, data that you have, and then that's all you do. Not try to be too fancy, just try to move something. The Red Queen effect means if you don't move, then somebody is going to come take your business and start where the data is. And in all of it, the thing that I keep coming back to, and the systems that I built before, I felt very proud of them, and I built them too strong, and I built them to last. You shouldn't do that. You should be ready to throw away the 4 hours that you spent on a sales call to build something that happens to work and is potentially a cornerstone of, if you fill it with real data, is something that does what you would have asked an intern to do on a week internship. That's usually the metrics. If you can ask an intern with very little social skills, very little awareness of the world, to go, I need you to look If you see this, then you mark it on the spreadsheet. Otherwise, just make us coffee. That is I wouldn't be rude to an intern, but that's what people do. That's what you would ask your first little deep learning to do. All right, thank you. Any questions?
Thanks, very, very good. I think you were telling that the models need to be trained kind of. How does that work in practice? If you can still elaborate a little.
Training, you mean? Give me
the
your
models
data
to
example.
match better the actual kind of desired outcomes.
Okay.
So is the platform doing it for you, or
yes,
do you do
yes.
it as a data scientist?
Very, very good. Let's do that quickly. So here, let's duplicate. We could just try to do it from scratch. So I can build a model and say I have some kind of input. I want to put a dense layer, dense layer, dense layer. And usually this is if you build something in Keras and you say I have a piece of, let's say, that's a good example, a spreadsheet with a column. That column would be the thing that you try to predict. And you would say the input would be all the columns, like 1 to 5, and the prediction, the output, the target is number 6. Dense layer is a way of, that's a representation of 1,000 nodes or 100 nodes, all initiated with random weights. Not your problem, it's the platform's problem. But this shape, once you train it, let's quickly put a little target at the end. And input is going to be in, output, out, and that needs to match the classes you're doing. Okay, so this is red because it says it makes no sense that you're putting a multi-dimensional thing like 224 down, 224 across, and 4 channels deep information into a dense layer. So I'm going to break that line and say I'm going to put a flatten here. Now everything will be fine. So this is going to be an utterly terrible model because it's going to take a picture in, rip all the pixels and the colors apart into 200,704 individual values, multiply that 1 by 1 to 1,000 nodes with random values, forward to 2, and then the finger at the end of this model is going to say old or new brand. In this case, you can say how many pictures at any one time, how long it should run. An epoch is for an entire training set and a validation set to be used to train the model. That's 1 epoch, and we'll be doing that 100 times. So that, in the running through of an epoch, is a training. Let's do that. Let's train our utterly terrible model. So what activation function is in there by default? Mean squared error, okay. So it's not going to be comparable to the other things we did today, but right now, what's happening is somewhere in a GPU of a computer on Google Cloud, there's a mathematical representation of the things that I drew on this board. And batch by batch, 32 batches at a time, 32 pictures at a time. Can I remember? 32 pictures at a time. It's going to be loaded in, and it's going to be ripped apart, and the model is going to do, it's going to be multiplied forward, and it's going to guess wrong at the end, new brand or old brand. And when it doesn't match what the model knows about those individual pictures, it's going to say, all right, 1 layer back, you caused the wrong thing to lift up, the wrong neuron to activate. Therefore, you need to go down from 0.5 to 0.3. The other one needs to go from 0.5 to 0.7. The ones below that, behind that, the same. So it's adjusting the values stored in those neurons. There's also a bias, which is static. And then you do that back through. You can see how many. Somewhere there is an indication of how many neurons you're using. I can't see it now, but usually, let's stop this. I'm embarrassed about how terrible this is. Let's duplicate this. In this case, what should we change? Yeah, different optimizer. So there's the optimizer this is the kind of math that I don't understand. I've read up about some of these, but this is how you find the local minima. Right? So effectively, maybe help me with the wording here, but stochastic gradient descent, this SGD, would be a way of doing differential calculus going back to find out what the values that you're changing during that propagation should be set to, what it's doing and what direction. Usually is mapped out as a three-dimensional space with hills and valleys, and you need to find the lowest possible point. The lowest point is the lowest error, and your model's the job during training is to reach the lowest error, because then you know that you have some kind of representation of the input to an output that is most usually correct. So that's the job. That's the job of this thing, which is eta grad, which is different from before. Different leading rate, fine. Decay, I'm not sure. Go. So now this is comparable to the models I built before, because I duplicated it, and it uses categorical cross entropy, meaning this function that says how wrong are you when choosing just left or right. Okay, so check this out. My other models, if I zoom in down there, had a, okay, well the scale is completely off. My error was something under 1, 0.9, and it goes from 0.9 to 0.7, maybe it spikes to 2 and then down to 0.01. And choosing this other optimizer has made me start at an error of about 10. And then over time it goes down. This dark line is my validation set. So when you train, you've got data that you're going to train on and data that you're going to use as a policing mechanism. So here's data that you allow the model to see. Here's a picture. It should be new brand if this is wrong, and you help it. And then once it has a training batch, you go, great, now this batch that I haven't shown you before, run it through, and if it does badly on the bit that it hasn't seen, then you know that it hasn't generalized properly. It doesn't have an idea of what it's seeing. It's just lucky in that the batch that it saw and the weights to adjust it, that it got to a lower. Okay, so let's go in. Wow, look at the scale. Man, there must be a better way. It's slightly broken. It's supposed to. What if I tag this as something else? Let's say it tags live. I want to just see the things that are live. Okay. I'm not sure this is correct, but let's stop there. So now I can actually put this in deployment and see how it works. Flick it on, yes, deploy, and there's my contact surface. I still called it image, that was the input. It was a JPEG, and we'll give it a picture that we know is a good one. Old brand. That's pretty interesting. And again, you were sitting here when we built the thing that is now saying thumbs up or thumbs down. There's nothing else that you have to do.
Summarize, there needs to be a person to operate.
Very much.
Yeah. Then one more question. We have a stream link there was about the use cases. If you can, there was an on-brand use case or POC here, but you can keep on use cases.
Yes. That's an excellent question because
we are actually wrapping up, and if you want to talk to Oliver, he's like a use case guy. So we will have a closer remarks outside, and then you can stay for a minute.
Okay. I know this is perhaps not the. You see that white outline of a dog? That's a Dalmatian. So in this data set, It's from the MS Coco dataset, all the dogs. The pictures of dogs were taken out, and somebody made a mask, meaning this picture is completely black, except the bits that corresponds to the dogness in the other picture has been flicked on to be one. So if you give this to a model, in fact, if we build one here,
what do you see normal users of this platform? What kind of data scientist throws in your head, or what is it called?
what's their skill level or their job title?
What's the skill level you see using this platform? Rather than coding themselves the 46 lines that you showed.
So it's an interesting problem. I see myself as a hacker or a product maker. I'm close to the domain expertise of, does this chest scan have cancer in it or not? And I want to get the prediction out so that I can build an app for a hospital that says you immediately have your chest cancer results. So I am not a developer. I'm not a data scientist. I'm in this domain expertise role. We're making this platform for the domain expert user. It needs some data science knowledge and some developer knowledge to build and prep the data set. So we're not perfectly fitted to the maker role at the moment. It's currently a cross between a developer and a data scientist.
Is there anything built in, like a happy face, sad face? Why would I have to train it? Can I buy that kind of model ready?
Yes, yeah, you can buy that from us.
So I don't need to train anything, but to have it already there for sample different industries. Right?
I want to show you something quickly. This is a model you could take off the shelf. Under snippets, it's called tiramisu because it's got multiple layers. So this corresponds to the simple little model you saw me do a couple of seconds ago. The input is way at the top, and the output is way there at the bottom. And if you give this massive model a picture of a dog and the mask of the dog at the bottom, you are training it to say, whatever this is, I want you to switch on over the mask, and it happens to be a dog. So this was a joke. But if you give this contracts with hand annotations for where the signature is, you give it 10,000 signatures. You could say, are my contracts signed? Which is a pretty interesting thing to say because a model can just look at a page and go, I can't highlight any hand annotations because I know what those look like. I have 10,000 examples of hand annotations on a page. Maybe it has a squiggle there, and that's what it highlights. You go, that's not in the realm where it says CEO, blah, blah, blah. And then you just flag it up saying, this contract isn't signed. So this is something that only deep neural nets or people can do. Even tabular data sets like telco usage, you can do with XGBoost, or you can say each little area, something that acts as a feature is an embedding into a deep neural network, and you can predict. In that case, your domain expertise of what it is you want from the data is all that you need, because the piece of work of how do I drive this thing, you pick up the phone, you speak to me. And if I don't know, I speak to one of the PhDs in the back.
Also, to add on the 46 lines of code, that's only in like the sandbox picture I showed you. So you don't have, with those lines, you don't have like a model in production. That's just to build a scope.
Magic. Thank you for your attention. I appreciate it.
Okay, thank you very much.
Thank you.